My name is Luke Bolstad, and I research dictyostelium discordium multicellular response to various substrate stiffnesses. Now, in order to understand this for you non-science audience out there, I want to introduce that cells respond to different physical stressors in different ways. So if you take this baby or a cell and you give it light weights, it's going to end up looking like this guy. But if you subject it to heavy weights and lots of training, you're going to end up looking like this guy. Now, this is prevalent for stem cell research. You can also think of these cells as blank slates that are going to change into many different types of cells throughout the body. These different cells are going to have their preference for what physical stressors they can withstand and what they can't withstand. Much like these soft feet, they cannot withstand these rocky surfaces, but they can withstand these softer surfaces. Unlike the soft feet, if you have hard and calloused feet like these elephants, you're going to be able to withstand rocky surfaces or intense physical stressors. Now, stem cells are expensive to work with, so we chose dictyostelium discordium as they are cheap and an easy test subject. These cells have a single cell state and a multicellular state. Previous research has shown that the single cell state and the multicell state do not have the same response to the same physical stressor. This research investigated why this is. We're going to be focusing on the multicellular state, and our first research objective was to understand what is the effect of different physical stressors on multicellular slug development. Our second research objective was what are the effects on slug development if you disrupt the communication of the physical stressor to the slug. In order to conquer our first research objective, we took our slugs, or our multicellular state, and subjected them to 3 different types of physical stressors. And then we measured the slug development in the form of the number of slugs formed, the length of the slug, and how far the slug traveled. To conquer our second research objective, we took normal cells and had no disruption, which would allow the slug to change its behavior, indicated by this yellow light bulb. But for the mutant cells, or the PAX-B slug, we disrupt this signal, and there should be a difference in behavior indicated by no light bulb here. Our results showed that for the wild type, or the no disruption of signal, there was no difference in the number of slugs formed on the 3 different physical stressors. This is the same for the distance traveled of the wild type slug in response to our 3 physical stressors. This is going to be a common theme throughout this presentation, so bear with me. The length of the wild type slug in response to our physical stressors is also not going to differ. For the PAX-B slug, or the slug that had the disruption in the communication of the physical stressor to the rest of the slug, we found no difference for the number of slugs formed in response to the differing agar concentrations, or our differing physical stressors implemented. The same is true for the distance traveled by the PAX-B slugs, and it is also same for the length of the PAX-B slug in response to our agar concentration, or our 3 physical stressors. So in conclusion, for our research objective 1, we found that the implementation, or the subjecting these slugs to different types of physical stressors, elicited no difference in slug formation, slug length, and slug migration. For our research objective 2, we found that while we thought that there might be a difference in behavior for the mutant cells compared to the normal cells, there actually appeared to not respond any differently when we disrupted the communication between the physical stressor and the behavior of the cell. Thank you for listening, and I hope this is enjoyable.